terminology. Yeah. Foldable is still folded. The back of the foldable should be blank. In the upper right-hand corner, write dilations. This is where the notes on the next page are to be written. And I did a picture for you all. You know how time-consuming that was to draw? Did you flip over the right side? Did you flip your foldable? You need to reflect it? Yeah, you're good. So did I say upper right-hand corner? Okay, what did I do? It is in the upper left-hand corner, so I don't know my right from my left. So are we ready? Dilations are not isometries. They are not. What do isometries preserve? Length and angle measure. Properties do not dilation does not preserve length. However, it still preserves angle measure. A blueprint. The floor plan of a blueprint is the dilation of the actual floor plan or the actual floor plan of your house when it's built. Dilations do preserve the orientation of vertices. Why are these going to be a whole lot more noticeable than the other four? Right, they're going to be different sizes. One's going to be big, one's going to be little. But the orientation does not change. And again, it maps each point of the pre-image to only one point on the image. And, you know, it's just amazing how we can take geometry and algebra and similarities. When you see this wording, when we're in algebra, that's called a function. And we have that same one-to-one deal in geometry. Have you gone through, can I roll this up to B? Or do you still need A? All right, the scale factor. Is the size of the dilation. The lengths of the image are a multiple of the corresponding parts of the pre-image. And our scale factor is always image length over pre-image. I want to play with that a little bit more. Tell me what's preserved. in a dilation? Angle measures preserved. What is not preserved, Kayla E? Length. All right, so I want to kind of combine or connect E to F. This says the lengths of the image. I'm going to do I for image. Maybe I'll just write it out. Image, all right, equals some number times the pre-image. That's what it means to say the lengths of the image are a multiple of the corresponding parts of the pre-image. So now if I were to take this that we just wrote, I'm going to clone it, we're going to move it down here, maybe. And I were to solve for this number, and it's connected by multiply, what would I have to do? Divide. And I would divide by what? Pre-image. And I guess this should be, I mean, this is technically image length. This is pre-image length. Pre-image length. So this is going to be divided by the pre-image length. Do you see how we got that part F? Image divided by pre-image. I need you to either remember image length equals number times pre-image length, or this ratio, one of the two, because if you have this, you could solve it over to here. This special number deal, what is this number called? This number, when we're finished, is going, oh darn, that is not a highlighter. This number is going to be called the scale factor. All right, here's our notation. What does this mean? This means a dilation, and actually I should say D in comma C of figure. Technically is how it should be written. A dilation of the figure by a multiple of n with respect to center C. This is what you're going to do in your project to your floor plan. To the two rooms that I've assigned you, you are going to do a dilation. A dilation is either an enlargement or a reduction. And you're going to be doing an enlargement because your floor plan's already tiny. And I think we're going to do it not on graph paper, I've decided. I'm going to do it on regular paper. All right, so let's see how we're going to work with this. I think one day we're just going to do a notation summary. So now on your foldable, you should have all the important information about every single transformation. This is the last one we're learning. Now we can do compositions of all sorts of these that are not necessarily glide reflection. All right, dilation with center C and scale factor n, where n's greater than 0, can be written as such. The properties of dilations. Now you can either continue this on your foldable or you can go to your new sheet of paper. the image of C, the center, is itself. For any other point R, R prime is on ray CR, so that means a ray starting at the center, passing through R, and the distance from CR prime is equal to that scale factor times CR. And this is what I said, the image length equals some number times pre-image length, or scale factor is the image length over pre-image length. That's what B is saying. B is E and F on your foldable. Dilations preserve angle measure. They do not preserve length. So we need to look at this. And we can do this. This is pretty easy to do with a compass and straight edge. D, yeah, little n comma big C, where n is your scale factor and C is your center of dilation. Devin, what do dilations not preserve? Okay, they do preserve angle measure. They do preserve orientation. It is length. What kind of transformation doesn't preserve orientation, Caitlin? Doesn't preserve orientation. What transformation does not preserve orientation? Do you have your foldable? Take a peek. Translation does preserve it. We want to know what does not preserve it. Reflections do not preserve orientation. One more. Correct. All right. So now, an enlargement is a dilation whose scale factor is greater than 1. A reduction is a dilation whose scale factor is less than 1, but greater than 0. All right, now in order to answer the question as far as enlargement or reduction, you have to know who was the pre-image and who was the image. You with me? So who's the pre-image? MJ? Okay, and why do you say it's A, B, C, D? Doesn't say prime. So the image is going to be what, Becky? A prime, B prime, C prime, D prime. All right. So in order to answer whether it's an enlargement or reduction, you have to take your eyes on the pre-image, then your eyes to the image. Did it grow or did it shrink? Kayla? It shrunk, meaning it is a reduction. All right, if it's a reduction, so how do we figure out scale factor? There's one of two ways. We can say image equals some number n times pre-image, at which point we see a 4 that corresponds to a 12. 4 is the image, 12 is the pre-image. How do I solve for n? Travis, how do I get n by itself? Are they connected? So how do you undo that? Okay, what's 4 divided by 12? 3 or 1/3? 1/3. So this was a reduction by a scale factor of 1/3. What's the other way you could do that? You could say, well, scale factor, if you recall, it's image over pre-image. Lost the I in there. Anyway, you got the idea. The image is 4, the pre-image was 12, and the scale factor is 1/3. I don't care if you do it in the orange or if you do it in the green. I need you to be able to do it. So whichever you prefer. Okay, let's look at this one. This is center of dilation is A. Enlargement or reduction, Devin? How do you know? Okay, so we're looking at WERTQ mapping to W prime, E prime, R prime, T prime, Q prime. Scale factor. Jennifer, how do you want to do this scale factor? Do you want to do image equals n times pre-image or in the fraction form? Your choice. What do you like best? Okay, so our scale factor n is going to be who's on top. Which is which one? The WERTQ is the pre-image. The W primes are the image. So who will go on top? Right, so what number? 15 over 3, or 5. So in other words, every single one of these sides was multiplied by what? 5 in order to get these sides. Do you see the center of the center of dilation is in the center? And we've got parallel figures. Here it was one of the vertices. So we've kind of got one inside the other. It doesn't really matter. That's an enlargement because the non-primes map to the primes. We start here and we got big. With me? Okay, here the non-primes were big and the primes were little. So we went from big down to little. Here we went little to big. It's so important that you identify the pre and the image. So if you can answer this question correctly, in essence, am I testing to see if you understand who the pre-image and image are? So that would be like a double assessment on one question. All right, which triangle? So now they're telling you the dilation, scale factor n about I of TIR is equal to triangle FIN. Which triangle is the pre-image in this notation? MJ, which one is the pre-image? Look at my notation. Right, the pre-image is TIR. So that means triangle TIR is mapping to triangle FIN. So Bree, is this an enlargement or a reduction? It is a reduction. What is the center of my dilation, McKenna? It's one of those vertices. Correct. The center of dilation is indeed I. Okay, I need scale factor. Now look at this. Is this a side of the image? A whole side? Yes? Okay. Is this a side, the blue only, is that a side of the pre-image? Or is that part of the pre-image? It's part of the pre-image. What's the whole length of the pre-image? 9. So if you're going to go for scale factor is going to be image over the pre-image. So it's going to be 4 because that's part of my, that is the side of my image. Not to 5, but to what? 9. So this is a reduction. So if I wanted to fill in this notation, this would be a dilation of a scale factor of 4/9 about the center I of triangle TIR. And that gives me triangle FIN. So the scale factor is 4/9. All right, are they going to do this to you a lot? Yes, they will do that to you a lot. Mm-hmm. Yes. So see, there are no primes in this notation. There are no primes. Primes make it easy to know who's the image and who's the pre-image. So how would we do this scale factor? If GRIH maps to TRAP. Brittany? TRAP is the pre-image? That is the pre-image. And this is the image. So is this an enlargement or a reduction? It's an enlargement. How do I do the scale factor? Okay, it's image over pre-image. What's the image number? Yes. And what is the pre-image? 8. Okay? This whole side is the image, so that's a total of 11. That is the pre-image. What's the center of rotation, dilation? R. All right, so this says do the dilation x, scale factor of x about the origin. And when we do this on a coordinate plane and we've got a scale factor, you take each coordinate and do what to it? Carlin, what are we going to do to each coordinate? There's my scale factor is x. Actually, my scale factor is n. My scale factor is n. What will I do to each one of these? You're going to multiply it by the pre-image. It says for this course, dilations in the coordinate plane will have the origin as its center of rotation. So if I want to do dilation of scale factor 2 about O, the origin of point P, here's my point P. It's 1, 3, correct? So that's going to be 1 times the scale factor, comma, and then y times the scale factor, which gives me a p prime of 2, 6. So I went over 2 units, 1, 2, 3, 4, 5, 6. 2, 6. So to transform point P, the new coordinates will be 2, 6. Was that hard? Okay. Now we want to do, so notice the center's gone. When there is no center, what are they assuming it to be? Pardon? The origin. All right, so we're going to start with Hope. Hope, what's this ordered pair? Hope has W. Nick, you've got O. Karen, you've got H. And Eric, you've got S. So think about your coordinates. Hope. Okay. Nick? -2, not quite. Oh, yeah, you are. This is 4. X. All right. So, Karen? This is going to be what? 3, 5. And then Eric?
4, 1.
All right. So if I am going to do this dilation, we're going to start with Samantha. What does W become? W prime. It's going to be -4 times what? Over 2, comma, 1 times what? So W prime is going to be -2, 1/2. All right, let's go with Sydney. How do we do O prime? There's my scale factor. Half, comma. All right, and that's going to give you -1, comma 2. Am I showing my work? Will you show your work? If you want credit. How about H prime? Let's go to Leslie. H prime.
3 times 1/2.
And?
5 times 1/2.
Or 3/2, 5/2. All right. Carlin, you've got S prime. It's 4, 1.
Is it 4 times 1?
Mm-hmm.
Okay.
Right. So that's going to be 2, comma 1/2. So now if we go to plot this, we're going to go -2 up 1/2. That is going to be W prime. We're going to go -1 up 2. That is O prime. We're going to go over 1 and 1/2 up 1, 2 1/2. That is H prime. And then we're going to go from here over 2 up 1/2, and that's S prime. So this would be its image. I didn't do that very well. All right, so let's say this had already been graphed, and let's say I didn't know the scale factor, all right? If I want to find the scale factor, I would look for either a horizontal or vertical line because it's easier to do the length. This length is 1, 2, 3, 4, 5, 6, 7, 8. That's the pre-image, so I put it on bottom. The image is 1, 2, 3, 4. What does 4/8 reduce to? 1/2, which was what? Our scale factor. There's another one that we're going to multiply by 2. Uh-huh. So you've got A35 today. We've done A34, right? We didn't do A34? Maybe what I should have said is that I assign A34 rather than did we do A34. I've never assigned A34. That's what. Who has a syllabus? I want to make sure we got this right while you all are here. We should be on CC 15. It is A35. I assigned CC 12, didn't I? Okay. Yeah. So that's A35. A35 is the correct one, yes. I'll take it. Okay.
Because Friday, like, I did the wrong bit, and then you were like, okay, so
Okay.